To do this problem, I'm going to first label equations 1, 2, and 3. I would call the first one as equation 1, and the second one as equation 2, and the third one as equation 3. I'm using solving system of linear equation, addition elimination method, and also back substitution after I delete at least like 1 or 2 variables. So the first thing I'm going to do is, again, there are different ways of solving this problem. So what I'm going to do, I'm planning on eliminating one variable first. So we'll see what happens. So what I'm seeing is equation 1. And since I'm seeing the variable coefficient of x, and that's what I'm focusing on. So the first thing, let me write it on the side. So 2x plus 4y minus z is equal to 15. And x plus 2y plus 4z is equal to 12. That's the only two equations I'm focusing on now. Now, since I'm seeing the coefficient of x here as 2, I know if I have to eliminate the 2x from this term, I need to multiply this entire thing by a negative 2. So that will yield this equation as negative 2x minus 4y minus 8 z is equal to negative 24. So my first equation is 2x plus 4y minus z is equal to 15. So if I add these two, this gets cancelled up, this gets cancelled up. So that's giving me a hint that these are dependent systems. And then I'm giving a negative 9z is equal to negative 9, or z is equal to 1. So now if I take back z1 and plug it into these equations, I will get the first one will become 2x plus 4y is equal to 16. So this is my new equation 1. And the second one will become x plus 2y. So this 4 times 1 is 4. 12 minus 4 is 8, right? So that's my second new equation. And the third one I would do is x plus 2y. And if I get negative 2, I'll get an 8 here too. So this is my third new one. So if you see here, the second and the third equations are the same. So they are dependent systems. But on the first, if I factor out a 2, it'll be x plus 2y is equal to 16. And then if I divide out the 2, I would get an 8 here, which would be the same thing. So I'm ending up with 3 same equations. So this is a dependent system. So that tells me that it has infinite many solutions. So here in the problem, it's saying if you have infinite many solutions, then express your answer in terms of t. And the hint is given is you have to call y as t. So let me call my y as t in one of these equations. So x plus 2t is equal to 8. So therefore x is equal to 8 minus 2t. So since x is 8 minus 2t, if I go back and plug it into one of that equation, 8 minus 2t plus 2y is equal to 8. Subtract the 8 minus 2 to the other side, so it's 8 minus 8 plus 2t. So this would get eliminated. 2y would be equal to 2t, or y would be equal to t. So that's what I'm started with, right? So I'm getting my y equals t. So these are the 3 answers. Y is t, x is 8 minus 2t, and z is 1. So when I put my answers in, I will write the x value first. So 8 minus 2t, then I put a comma, I will write t, and then a 1.